As we approach severe weather season, the atmosphere changes from a wintertime pattern to a summertime one. With that clash comes instability in the way of severe thunderstorms and the worst possible outcome, tornadoes. While states such as Oklahoma and Kansas are known for tornadoes, there has been an uptick of tornadoes further east. So why is this happening? Let's find out. A tornado is a rapidly rotating column of air that is in contact with both the surface of the earth and a cumulonimbus cloud. Tornadoes are formed within powerful thunderstorms when warm, moist air at the surface meets colder, dry air aloft, creating an unstable atmosphere. The interaction of these air masses, along with wind patterns and atmospheric conditions, can lead to the development of a rotating column of air, which may extend from the cloud to the ground and become a tornado. Around 83% of tornadoes occur exclusively in the United States, and a lot of them occur in Tornado Alley, a zone within the Midwest between the Dakotas and Texas. In recent years, there has been a noticeable shift in tornadic activity eastward of Tornado Alley, into states within the Southeast, Eastern Midwest, and the Mid-Atlantic. In today's episode, we're going to try to find out why this is happening. First, we'll identify the seasonality of U.S. tornadoes and how that plays a role in their formation. Next, we'll look at which states within the new area are seeing substantial upticks in tornadoes. Then finally, we'll investigate reasons behind the increase and if other areas of the U.S. may become more affected by tornadoes. Before we begin, if you enjoy learning about geography and earth science, you found the right YouTube channel. So be sure to subscribe to my channel, Our World, Our Planet, Our Home. Let's begin. First, let's talk about the time of the year tornadoes form and the physical geography behind it. There are two distinct tornado seasons, with one occurring in the spring months from April to June, and another smaller fall season occurring from September to November. Around 70% of Midwest tornadoes occur during the spring season. In addition, tornadoes are also common throughout the summer, where there is warm air available in the atmosphere. But the reason why the changeable seasons see enhanced tornadic activity is because of the temperature contrast. During the spring and the fall, temperature fluctuations are more erratic. The erratic nature of these changes mixes together, whereas warm moist air from the south meets up with colder dry air from the north. When two opposing air masses meet up, this destabilizes the atmosphere and creates storminess. The instability can be so increased that supercell thunderstorms develop, which feature heavy rain, high winds, hail, and lightning. If the instability increases further, this creates a ripe environment for tornadic development. But not all tornadoes are equal, and that some are weaker and some are stronger. This is rated on the Enhanced Fujita scale, a numeric scale which ranks tornadoes from EF0, the weakest, to EF5, the strongest. The more favorable conditions and instability, the more risk there is for stronger tornadoes. Geomorphology also plays a crucial role in why the U.S. sees so much tornadic activity compared to other countries. The central United States is relatively flat from the Gulf Coast to Canada. Without any blocking mountains, warm, humid, moist air from the Gulf of Mexico can easily mix with cold Arctic dry air from Canada. This is why the original Tornado Alley sees a large number of tornadoes, with some of them reaching EF3 or higher. Although the original Tornado Alley still sees many of the U.S.'s tornadoes, there has been an increase in the number and intensities of tornadoes eastward. In the last few years, there has been some notable tornado outbreaks in states such as Louisiana, Mississippi, Alabama, Tennessee, and Kentucky. From December 9th to 10th of 2021, a tornado outbreak in the states of Arkansas, Missouri, Illinois, Tennessee, and Kentucky produced 71 confirmed tornadoes. The largest of them was an EF4 tornado that went through western Kentucky with winds of nearly 200 miles an hour. The town of Mayfield was destroyed, and unfortunately 57 people lost their lives. From March 24th to the 27th of 2023, a tornado outbreak occurred in the southeastern states of Arkansas, Louisiana, Alabama, and Mississippi. The strongest within the outbreak occurred in Rolling Fork, Mississippi, when an EF4 tornado went through the community. 21 lives were lost with this outbreak. A more unusual outbreak occurred on September 1st, 2021, when the remnants of Hurricane Ida trekked up the eastern seaboard. A very humid atmosphere coupled with moisture from Ida created an environment ripe for tornadic formation from Maryland to New York. In all, 35 tornadoes were confirmed, with the largest, an EF3, hitting Mullica Hill, New Jersey. An EF3 tornado in New Jersey is extremely rare. Now that we have reviewed the non-tornado alley areas that have seen activity, what are the reasons behind the uptick? One reason may have to do with the drier Midwest. Areas where tornado alley is generally see between 30 to 40 inches of rain a year, a generous amount. However, there have been some studies that have said that the dry line, a line dividing the wetter east and the drier west, has moved eastward. If this is the case, it would mean that areas such as the eastern Dakotas, eastern Nebraska, eastern Kansas, eastern Oklahoma, and eastern Texas are receiving less rain. Less rain means less available heated and humid moisture, which may suppress tornadic activity. Contrary to what may be happening there, it's a different story in the southeast and mid-Atlantic, as these areas have been receiving more rain in recent years. Moisture from the Gulf of Mexico, as well as the warm Atlantic Ocean, may fuel storm development, especially when mixing with cooler, drier air, contributing to an increase in tornadoes. Whether this trend is related to climate change or not is still debatable. Climate change may trigger such changes, but historically, there have been drier than usual periods in the Midwest, such as the Dust Bowl of the 1930s. Another reason is related to the warmth of the Gulf of Mexico and Atlantic Ocean. If both of these water bodies are experiencing above average temperatures, this can fuel moisture development, which can trigger severe weather systems, igniting tornadoes. Also, a warmer ocean temperature will mean a possible increase to hurricane activity. When hurricanes strike, they can create tornadoes within them. In fact, most of Florida's tornadic activity is triggered by hurricanes. Usually the southeast and mid-Atlantic states are more affected by hurricanes, so an increase in hurricanes can also mean an increase in tornadoes. Although most hurricane-induced tornadoes are weak, between EF0 to EF2 in intensity. Another oddity of eastern tornadoes is the occurrence of some during off-season times. The December 2021 outbreak in the upland south was out of season, considering that area is usually cooler and drier at that time of the year. And another concerning human geographical factor is population. The eastern U.S., especially the mid-Atlantic and eastern Midwest, tend to be more densely populated. If tornadic activity increases in these regions, it can pose a threat to more of a populace. Will areas outside Tornado Alley see more activity in the future? And is it related to climate change? It's very possible, however, it's not wise to rush to conclusions. For example, there were a couple of unusual tornado outbreaks decades ago. On November 7, 1966, there were 4 tornadoes that affected Southern California, with 3 reaching an F2 in intensity, affecting Los Angeles and Orange County. On April 5, 1972, 4 tornadoes affected Washington and Oregon, with 2 reaching F3 in intensity, killing 6 people and damaging many structures in and around Portland. Usually the West Coast is not thought of as receiving tornadoes, but these were 2 notable outbreaks. And if you go way back in meteorological records from the 1800s, there were some severe tornadic outbreaks in the eastern United States. Obviously, these can't be linked to man-made climate change. Still, there is a possibility that climatic changes, naturally or artificially induced, may be changing weather patterns. Another thing to keep in mind is urbanization patterns. In recent years, people have been settling in more disaster-prone areas, including tornadic ones, thus creating more risk. The U.S. population is going to keep growing in the 21st century, leading to more communities being built, with some of them being in precarious areas. These developments are going to be built whether or not the area is a high-risk zone for tornadoes or other natural disasters. The best thing we can do is prepare by building sturdier structures that could withstand higher wind speeds. Unfortunately, an EF4 or EF5 tornado usually produces total destruction, but homes and commercial buildings can possibly be built to withstand a strong EF3 tornado. Besides building strong structures, the good news is by living in the 21st century, there is more technology than ever put into weather forecast modeling. The National Weather Service is able to issue watches and warnings in advance, thus saving lives by doing so. That's the end of today's episode. Thank you once again for watching this video. I appreciate your support, and if you want to leave feedback, please do so in the comments section below. Also, be sure to subscribe to my channel, Our World, Our Planet, Our Home. Until next time!